start now. So welcome again. My name is Peter Ohwe, standing in for Professor Lubuseye in our third lecture. What we seek to do today is to first go around our classroom and show us the resources that are there so that we can take advantage of that classroom. The other thing that we are going to do is to begin to explore data science further. But today's session is a bit different from what we had in the first 2 weeks because this one will be practical. There'll be hands-on. So I wish for us to respond by, writing yes if you are on your laptop or desktop, and no if you are using your phone. Let's have an idea of how many people are using their laptop. Let's do that quickly, please. So Dr. Sheye Adeshe is on laptop. Fantastic. Yes. Oladekan Omosanya, yes, go on, man. Okay, maybe she's raised her hand that she's on laptop too. I think that's what that means. Okay, good. It's better if you are good. Everybody's on laptop. Brilliant. So let me go ahead, share my screen, and let's start covering today's work. Today's work is a very interesting one because we are now going beyond the fundamentals in the sense that we are not just focusing on the initial concepts, even though we are still treating fundamentals of data science, of course, but we are now touching on very useful aspects of this course. So introducing you to this page again, we ought to have done that at this. I hope you can see my screen.
Yes, I can see it.
Okay, good. So this is where we always join in from. But you can see that if you only come here to join the classroom, you would have missed some very interesting, resources. Here on January 28th, the course outline was, introduced, and then the registration link is here. So it's important for us, maybe by the middle of this program. Yes, we've started. So at the middle of the program, maybe in week 5, we can now ask people to re-register because there's a need for us to have that information to help us a great deal. In the beginning, it was only a few people that registered. And then over time, we now discovered that there were more people who were interested and that students also needed to learn this course. So that's why we've not been focusing on the course registration, but we need it for the purpose of data. It will be very unfair if we are doing data science and we don't have data in the sense of registered participants. So here you also have Professor Lubuseye's YouTube channel. This is a huge advantage. If I can click on that, and then we'll go to the YouTube channel, you realize that there are other resources. Data science does not stand alone. Okay, so in his channel where you can actually subscribe for other resources that are similar to this particular one. So if you can see my screen, you will see that in recent times, he has uploaded some interesting videos. This SDM is statistical data mining. This is still part of data science, okay? These quantitative methods in linguistics is still part of data science. So this is Local Studio, a visualization tool. So here you will see even our lecture. So it's important for you to take advantage of, those kind of opportunities. that you have. You don't have to pay for it again. You already, yes. So Felicia Fatoki, Ademola Phillips, Adegoke Yusuf, I see your hands are raised up. Are they deliberate? Or you want to ask me questions? Please, you can unmute if you want to ask a question. Today's session is going to be highly interactive. We will show you some interesting tools that are on this platform. However, if we raise those hands up accidentally, we can go on. So, introduction to data science and R programming, our very first lecture. The PDF is here loaded, and the recording is also loaded, including the transcripts of the meeting. So this is a place to visit. There's also quiz 1, which you are expected to, take. And within the time the quiz was up, 19 people at that time responded. But we are a lot more than that number now. And from next week, we'll start having quizzes on each of our lectures so that we can assess how much learning is taking place. Then last week, we did data wrangling and manipulation in R. Even though we didn't finish this particular, session, we will still come to it later, because by the time we get to practical applications of the different techniques under data science, we will see that the issue of data manipulation is reoccurring. Another thing that we can enjoy on this platform is opportunity to discuss. We can engage in conversations. Okay, so this platform is for us. Today's session will be on data visualization with R. But before we delve into that, we also have this portion for classwork. Okay, so I will encourage us to just try to visit this classroom. Just come to our classroom and you see the lecture materials, all loaded in the right order. And you can always get this registration link and the course outline, so that you can have an idea of how much we have covered compared to what we said we were going to cover at the start. If you look at the outline, we've done introduction to data science and R programming. We have done data wrangling and manipulation. Today we are looking at data visualization with R. We are going to be touching on all of these things. This is interesting, and we are going to cover it. And it even gets much more interesting by the time we start doing modeling and all of that, and then machine learning. So there's plenty to take in. And that's why today's class is one that needs to be very interactive. So that if there are things that you have missed, if there are comments that you need to make, you can actually today feel free to unmute and then ask us to revisit some of those things. Then there are people in this class, there are students and there are teachers. And finally, this portion of grades, which I don't intend to show you. So back to class. Any comments at this point? And by the way, the number is low. I learned that the other week, last week, there were people at maybe on campus who joined. But if we are having 11 people today and there's not such arrangement, then the number is really low. Somebody wants to respond and educate me so that we have an idea of how many people are actually participating, because today's class is so important. I wouldn't want you to miss it. Dr. Ademola Phillips, HOD, want to tell us that some of our colleagues are somewhere joining, or is
I'm with you.
Yeah, I see that the number has dropped. Is there any issue, or is it that people are joining late today? Do you have any information?
As at now, I don't have any information as regard that. I'll
Okay.
find out what is happening.
Okay. All right.
I expect much people to join.
Yes. I was looking forward to so many people joining because of the lecture for today. Okay, so without wasting too much time, let's go to
Maybe
today's lecture.
maybe they
Yes.
will be joining us later.
Okay. Maybe. Okay. All right. No problem. So let's go to today's material, data visualization with R. If you're on your system, I will want you to do, I want you to open to this site. Just go here and open this so that you can download this file and also download this file. We are no longer, in preliminary lectures. We are now doing serious work. And if somebody decides to miss today's lecture, it will be difficult to catch up. So let's download this. You only need to click on it and then you download. Then you download on the second one. This one is a CSV file. This is the data, Excel sheet, converted to comma separated version of it. Then this is the R code. So the code that you usually ask for, today we are providing it so that you don't need to write the entire thing. It's already there. So for now, download this file and also download this script. Okay, if you have done that or if you're about to do that, I'll
Please,
open our.
how do I go about that? I don't know.
Okay, great. So those are the things that I expected today. So thank you very much. What I'm going to do is this. I'm going to stop my screen and then we'll help a few of us. So who was speaking then? Olugbode Adeoye, am I right?
Amasanya.
Do you know how to share your screen?
Ah,
If you don't, I can help you. Are you on your computer? Amasanya.
yeah, I'm on my computer.
Okay, I'm going to share my screen and I'll tell you what to click on your own screen. So just
Right.
watch my screen as I share. And this goes for every other person. It's important. We need to do real practical work today. Can you see my screen now?
Yeah, I'm seeing it.
Okay. Can you see my cursor?
Yeah, I can see it.
Okay, so can you see where this raise hands is?
Yeah, I'm
Then
seeing it.
then you can see this arrow.
Yes.
So you are going to click on that arrow. When you click on that arrow, have you done that?
Yes.
What did you do?
It's off. It's off again.
No, not me. On your own screen. When you click on that arrow, it will show you a window. You will see something like Chrome tab, window, and entire screen. Did you see anything like that?
No.
So when you click on that, what did it show you?
I'm only seeing the other people and I
No,
cannot
no, no,
see it.
no.
I cannot see
No,
your
no, no,
screen
no.
again.
Minimize the meeting. Or
Yes,
can you see my screen?
I'm seeing your screen. I've minimized the screen.
Okay, if you can see my screen on your when you project this class, you will see the pictures of participants. Then you will see here where you have raise your hands. And then you
Yes,
will see this arrow. Can you see this arrow?
yeah, I'm seeing it.
You have you have it too, not
Yes,
my own. You also have it.
yes. It said this will yet take you over to Peter Zake as the main presenter.
Okay,
Share
so good. Let me
or
stop mine.
cancel.
Let me let me let me stop mine. I want to stop sharing my screen. And I want you to share your screen. That's part of what I wanted us to look at today, so that you'll be able to share your screen Yes,
Okay.
we are doing data science, but when you want to teach people also, and you want to use platforms like this, you need to learn it. Okay, Yusuf, are you raising your hand? You have a question too. And by the way, is there anybody here who is able to share his or her screen? Let's use that person to demonstrate what we are saying. Anybody?
I'm seeing select window or screen.
Okay, good.
So
You select screen. Select screen.
select screen
Yeah.
or select window or screen.
No, select screen. Pick screen.
Okay.
Yeah,
Need
doctor.
permission.
Okay, you need permission to share screen. Where do I get that now? You need permission to share screen. You say you need permission to share screen, right?
Yeah.
Where do we get that permission from?
Mhm. It said you must grant permission in order to screen
Yeah,
share.
so send me like a request. There's something, I think you send me a request. There's something that you click, then I will now accept it, I think. Yeah, let's go to the other participant. Obo Ismaila, Salisu Michael, Dr. Ademola, Olubode Adeoye. Let's hear you. Are you able, do you know how to share your screens? Yeah, Obo, go on. Ismaila.
Hello.
Yes, doctor. Do you know how to share your
Yeah,
screen?
I've been able to. Yeah, I've been able to click the arrow, and I got to a place where Chrome tab, window, and entire screen.
Click on entire screen. Pick entire screen.
Okay.
When you pick on entire screen, you now just click on that square on your left.
I've done that.
Yeah, so you should now present your screen. You know, when you click on entire, yeah, your screen is coming up. Brilliant.
Are you seeing my screen too?
Yeah, I don't know which screen I'm seeing now. Olalekon, yeah.
Almost Dr. Mosiah.
Correct. So we are seeing doctor's screen. And that's very important. And I'm glad we're able to see that. Yes, I'm seeing Adedeji, Adeshina's screen. Yes. Yes, I'm seeing Dr. Ademola's screen. Fantastic. Good. Now, so let's settle with Dr. Ademola's screen.
Okay.
And so doctor, can you go to, you know, on your browser, there is class invitation, there's data science fundamental, there is, oh, somebody else is sharing. Everybody's trying to share, which is good. But what I want to do is,
there is an arrow saying stop sharing. Should we stop it?
Yes, all of you can stop sharing and let one person share so that I can use that opportunity to show us how we can, you know, download the data set. It's important. Today's class is very practical. Yes,
I have stopped.
Yeah, who is sharing now? Dr. Ademola, you want to share your screen? Two people are presenting screen. Can Dr. Adedeji Adeshina stop presenting? Dr. Adedeji, just click on stop sharing.
It's up there.
Yes, click there. Good. Yeah, fantastic. Okay. So somebody should just share. Let's use somebody's. I'm even already glad that at least we can now use that platform to show our work. The reason is that as we move to modeling and machine learning, there will be occasions when you want to ask questions, and the easiest way to show your question is to share your screen. So Dr. Ademola, you want to project your screen and let's show us how we can download our data set and download our R file. If we're able to download our data set and our R file, today's lecture will be very interactive. Dr. Demola?
Yeah, I'm trying to do that.
Okay, just go on. Just
So I
share.
have select the tab to share.
Select the tab to share. You use the entire screen.
Okay, yeah. Yeah, I have that entire screen.
Yes. Then you
So
now
what
click
next do I
on.
do?
You now click on the picture that you see on your left. Just click on it. It will bring up your screen to share it. Very good. Very good. So I was reading your tabs on your browser. The first tab I see is class invitation, data science. The next tab is data science fundamental. Can you see what I'm seeing? No, on your computer.
Not at all.
On your browser, where you have
Okay.
opened 4 tabs. There are 4 tabs open on your
Okay.
computer.
Okay.
Those things at the top. There's class invitation, there's data science, yes, exactly. So pick that second one. That second one. Fantastic. Click on that. Click on it. That should be if you click on it, that's what we'll be seeing. You're not clicking on it. Hello, sir. You're not clicking on it.
On the second one.
Yes.
Yes.
All of us are seeing your screen. You have stopped sharing it.
Yeah.
He has even left the class. Dr. Lalekon, you want to try it?
Yeah, let me do that.
Yes, we need to learn.
Are you seeing?
No.
Hello?
First share your screen. We can't see your screen. Even though I'm going to, yeah, your screen is coming up. We are saying we could also put the data on the platform. Fantastic. Good. Click on your own second one. Great.
Data science fundamental.
Brilliant. Good.
I'm there.
Good. Scroll down. Good. Go to that data visualization. Olusonya Olubuse posted a new material. No, you have gone past it. Go back. Yes, here.
Okay, this.
Yes, click on that. Fantastic.
Okay.
Good. So these are the materials that Professor Olubuse posted yesterday. That one that you are hovering over is the lecture notes. Leave that alone. Go to your right.
Okay.
That's your data set. Click on it. Click on it.
I'm there.
Very good. So now click on the open with. There's open with.
Where is that?
At the top. That thing is blocking it. That you are now sharing entire something is blocking it.
Okay, should I minimize?
No. Click on that. You see something that they wrote hide. Can you see hide?
ID.
No ID. So this is our data set. Okay.
Okay, let me click on the arrow.
No, don't worry. Don't worry. I wanted to stay here. Okay. I wanted to use this to explain to the class, which is something beautiful that we are going to enjoy today. So, data science requires data. In this week's lecture, we are looking at data visualization with R. We cannot do data visualization except we have real data. So here we have real data in the form of a spreadsheet. The title of this data is DF_CSV. Good. And this data has 7 columns. 7 columns. The first column is the name of the individuals. The first individual is Alice. Can you help me put your cursor on where we have Alice? Fantastic. Yes. The second individual is who?
Eve.
Correct. Now, apart from the name, we have other variables. What's the next variable? Brilliant. Next.
Salary.
Fantastic.
Department.
Great.
Gender.
Yes.
date,
Date.
region, and sales.
Good. Good. Very good. So how many variables do we have altogether?
Yeah, like 1, 2, 3, 4, 5, 6, 7,
Mm.
8.
So there are
Uh,
8 variables.
8 variables,
Thi-
including date.
This good. So these variables are also called features.
Okay.
We need to know that the columns are the variables and the rows are the observation. On your screen now, there are 25 observations that we can see.
Yes.
The last observation is David. If we go to
Yes.
number 9, we will see
Number 9.
Alice, 32
Yes.
years old. What's the
Yes.
salary?
His salary is
105,000.
105,946.
Which department?
IT,
Gender,
female,
and so on and so forth,
and
right?
so forth. Yes.
Right? Okay, so
Yes.
this is not data set that is too big. So now I
Okay.
want you to, if you see that blue thing where they wrote stop sharing, can you see it? Stop
Yes.
sharing. Good.
Yes.
In front of it, you will see hide. That next thing,
Yes.
click on that. Fantastic. Now click on open with. Click on it. Very good. Now go and click on Google Sheets.
Google Sheet. Yes.
Yeah, good. Click on that. So it will now open this as a Google Sheet.
Okay.
Now this Google Sheet is an
Okay.
online version of your Excel. You know,
Okay.
Microsoft have their own products. I'm going to mention, don't click on it, just go on. We are using your screen as our board for now. Okay.
Okay.
So
Yeah.
Microsoft has 3 platforms that I want to explain to us that we use for research usually. They are Google Doc, that is Microsoft Word, Microsoft Excel, and Microsoft PowerPoint. Okay, so
Microsoft Word,
yes, Microsoft Excel,
Excel,
and Microsoft
yes,
PowerPoint.
PowerPoint, yes.
Microsoft Word is used for writing documents. Microsoft Excel is for capturing data or
Okay.
for displaying data and recording data. And then PowerPoint is used for presentation. That's for
Okay.
Microsoft. But Google also has their own. So today we are looking at the Google version of Microsoft Excel. What you are
Okay.
seeing on screen is called Google Sheets. You can see it yourself.
Yeah.
On your browsers, you can see data visualization with R, and the next thing that is open is df_csv, and it calls it Google Sheets.
Yes.
So this Google Sheet is like Microsoft Excel. Does that make sense?
Yes. Yes. Yes.
So, but now what we want to do, because we are used to Microsoft Excel, is that we want to download this sheet. So go to file, look for where you have file, search for it yourself. File.
Yes. Same.
Click on it. Brilliant. Go to download. Keep going.
Yes.
Now, go and download it as comma separated. Come
The
down.
first one.
No, come down. There's comma separated.
Yes.
Click on that. Congratulations. You
Thank
have
you.
downloaded this file from the internet to your laptop. So it's
Okay.
now on your laptop. It is found in your downloads. I wish
Okay.
every other person could do that. But if
Okay.
not, this video is there for you to watch and rewatch. Now go to the other tab again, data visualization with R. Go there.
This place.
Click on it.
Okay.
Fantastic. Then go and cancel this. You will see that X on your left.
This.
No, not that one. Where, come down. Now go to your left, where you have the file name. Look for where you have df underscore CSV. Good. Click on that X.
Okay.
Click on it. So it has closed this. You have downloaded the file. Okay.
Okay.
Now go to sessions 3p.r. Click on that. Now click on download. So it's going to download that one. So congratulations.
Okay.
You have downloaded the R code and you have downloaded the data. But now your colleagues also need it. So go to our, do you have WhatsApp on your computer?
I do have.
Okay, don't worry. Stop sharing your screen and let me
Okay.
use my WhatsApp to share with the other colleagues so that everybody can have the two files. Like I said, today's class is very practical. I wouldn't know, yeah, if there's anybody who has also done the same thing and wants to. Okay, you want to stop sharing, right?
Mm-hmm.
Yes. So you go to your, I think you have more than one browser. Go to that Meet, that fourth one, the fourth one.
Okay.
So, yeah, click on that one.
Yeah, I'm back.
Right, stop presenting.
Okay.
Congratulations. The
Thank
latest
you.
data scientist in Ibadan.
Thank you.
Okay, so I'll share my screen now. I wish that the others were able to do that. So this is what we are going to do the first part of today's lecture. The second part becomes very, interesting and, amazing. Have you seen my screen? Have you seen my screen?
Yes, I'm seeing it.
Good. So I
Yes,
have
sir.
WhatsApp. I have WhatsApp on my system. Okay, so I think somebody sent a message. I have not received any link up yet. Wow. Oh, he has even joined the class, so it doesn't really matter anymore. So I want to upload those data sets. So can you see my WhatsApp? Is everybody seeing my WhatsApp? Wow. I think I've left the class.
Oh, you have.
Can you see my WhatsApp? Can you see my
Yes.
WhatsApp? Okay, good. So I will click on this plus. I want to attach the two files so that everybody can have it in class. I will go to documents. I've downloaded that file before. I downloaded it in downloads earlier today. So this is the file. This is the Excel file. So I will send it to the group. Okay, so I'll write, this is the CSV file for today's lecture. Then I'll send it. So we'll have that file. So even if you were not able to download that file on your own, now you have it, you can go ahead. The next file I want to give to us is the R code. So I'll do the same thing again. Go to this code, and then we'll have it. I'll say this is the R script for data visualization. I'm doing this because there are some people who are not in class, who are not here now, who might join later, and then it'll be easy for them to, get the materials. So that's all I want to do on my WhatsApp. So I go back to my presentation. And now I'm going to my notes for today. So that's the first part of my work today, to have you get the files. So let's go to today's lesson and let's cover the curriculum. When we are done with that, you will see the place of what I've done. So good afternoon again. Welcome to week 3 of our Data Science Fundamentals, and Introduction with R. Today, we'll be looking at data visualization using R. So we are going to upload our file. Okay, so maybe I'll take it from this stream. If we go to this stream and we scroll down, we will see that the latest file uploaded by Prof is this data visualization with R session 3. So I'm going to be reading directly from this screen. And I'm not going to be in a hurry. I'll try my best to explain the content, but at certain times I will stop and demonstrate using R code. And that's why today's class is very practical. Now, visualization is very important. Okay? It's part of what is referred to as exploratory data analysis. When you are dealing with non-technical audience, as statisticians, the use of visuals, things like graphs, plots, curves, they are very useful in communicating information. Pictures are very useful, instruments for communicating with both technical and non-technical audience. So data visualization helps when you want to explore and when you want to communicate. In fact, I can tell you that your proficiency in data visualization is enough for you to say that you are a data scientist. What do I mean by that? Your own area will be communicating using, visuals. And there are so many plots, graphs that you can use in R. Remember that our language of operation is R. Today, we are going to introduce you to a library, a package that is built for visualization. Before then, what are the common benefits of visualization? First, through visualization, we are able to identify trends and patterns. A simple scatter plot can show the relationship between two variables. The issues around regression and correlation, which are very common statistical concepts, are easily understood through visuals. In addition, another very important benefit of visualization is that when you have complex data sets, through that graph, you can get a summary of that complex data. So when you now have that information, it becomes easy in making decisions. You can see things like variables that influence others. You can see the relationships that exist among variables. You can understand the dependencies. And just by mere looking at that graph, you are able to make up your minds. Okay, we are going to see some of these benefits. We are going to eventually come back to them when we begin to demonstrate with practical examples. Again, there are certain insights that you cannot get when you look at numbers. Okay, so the numbers can be very clumsy, very cluttered, and unappealing. But when they come out in the form of maybe a bar chart or something, there you can see hidden insights. So visualization, not just in R, is important. How much more in R? Let me add that one of the strongest capabilities of R, apart from the other good uses that I want to remind you of, two good reasons for using R, and then a third one that I want to emphasize today. Number one, very good use of R is that the R package, the R software is free. R is free, open source. You don't have to pay for it. I'm reminding us of that in case we were not here in the first class. Second, and equally important, is that it has a lot of packages, a lot, okay? And a community that is ready and willing to assist when you have issues with your code. But out of all that, the one I'm emphasizing today is that R stands out as the best programming language when it comes to visualization. It has a lot of, advantage over other programming languages. So what are we saying? Today we are treating one of the strongest, features of our programming language. It is possible to use other libraries. In fact, if we can get to the last part of what I prepared for today, we will show you other libraries that can be used to produce elegant graphs in R and R Studio. Today, we are introducing us to ggplot2, where GG means grammar of graphics. This is a powerful package for creating data visualization. So if you are taking something home today, remember that today we looked at data visualization, and the package that we use is known as the grammar of graphics. And that is very instructive because it's not just graphics, it's graphics that communicates information. How? Because it is structured in a layered form where even the story of your plot is told by the script, the code. The code itself is arranged in a manner that if you understand the code, then it's easy for you to just adjust it a bit and then you have a different plot. That's what you're going to see today. We are going to have several types of plots, and sometimes we only need to change just a word in our code and we have a new plot. However, we say that ggplot2 is based on grammar of graphics and there is a layered approach to plotting. You can plot in stages. And once you have plotted and you are okay with what you have already, then you can stop at that point. But if you need further insight, then you can add another layer. This information will become very interesting as we progress. What are then the key components of somebody join the class? I just wish that those that have not joined now, or those that will not join at all, will be able to watch the videos and make sense out of what we are doing today. All right. The key components of ggplot2. The first one is to define the data set. And that was why we asked us to download the data. You know that we said that there's always a problem statement. There is no need for data science if there is no plan to solve an existing problem. The goal of doing this science is that there's a problem that we already understand, and we want to use a data-driven approach to resolve that problem. So there must be an existing data. So the first layer of our ggplot2 introduces our data. But here, it uses the ggplot function. As a reminder of what we have said in the last 2 weeks, whenever you see, any word, and then there's a bracket after it, that is called a function. So we use the ggplot function, but inside the function, we have 2 arguments. The arguments are the data. For instance, if you are trying to predict the outcome of an election, okay, and you have your data, and you call that data election. So it's election that will be here. If, on the other hand, you are trying to determine the cost of a building, okay, maybe you are an engineer, and then you see that your business is not doing too well, and you want to now become an estate agent or surveyor or whatever, and you want to determine the cost of buildings, and you now have a data set that you are using, to make forecasts, then that's what you put here. In our own example, we already have our data set. Our data set is DF_CSV. That's what you put here. Then you now talk about the variables that you are trying to display. Is it a histogram? Is it a scatter plot? What is it that you want to display? And that's what you have here in AES, aesthetics. Are you comparing two variables and you want one to be on the horizontal axis, which is X? Instead of writing X, you put the name of the variable. It could be gender. Of course, when it's gender, you know that it is going to be a categorical data. You know that it's not nominal. Or is it age? Which then you might need something like maybe a line graph. So here we are now bringing in ideas of our basic statistics. So on the first line, the first layer, you use the ggplot function, and inside that bracket, you capture your data, the name of your data, and then you determine the variables. The next line is to now determine the geometry. How do you want the plot to look like? And there are options. It can just be points, which is a scatter point, scatter plot. It can be bars, bar chart. It can be a line graph. It can be a curve. It can be heat map. It can be histogram. Okay, so here you tell us the kind of plot that you intend to, use. The kind of plot you want ggplot to reproduce. So ggplot goes to your data set. It captures the name of your data set data. It picks the axis X and Y, and then now produces a particular type of plot. You get a plot. At the end of this line 2, you already have a plot. But you want your plot to be visually appealing. Then you now add other properties like color, like size, and stuff like that. What is the first thing in trying to use ggplot? The first thing is to ensure that ggplot is inside your RStudio. If it is not in your RStudio, you will install it as a package. But good news, it comes usually with RStudio. So since it is not RStudio, your next step is to bring it to your file. What am I saying? ggplot2 is inside your software, RStudio. Just like having a file in your drawer. And then you want to leave the office. You have your bag, and you want that file to be in that bag. You have to take that file away from the library or your drawer and put it in your bag. So that's the kind of thing that is happening here. Yes, ggplot2 is in my RStudio, but at this instance, I'm going out to do a project. I want to use ggplot2, so you must fetch it from the library and drop it into your bag. So that's what happens in this line of code. I'm trying to simplify it as much as possible so that when you're writing the code, it will make sense to you. Because you see, like, since you are already data scientist, that's what I'm going to call you. You need to tell a story. The technical aspect of data science is good, but the communication part is better. You might have a very good solution, but you're almost always going to meet with people who don't understand your numbers and what you have done. So to be able to communicate that message properly, you also have to have a thorough grasp of what you have done. So that's what we have in this line. I hope I'm communicating. When you have done that, you are going to have your plot. So a demonstration is what we have here. In this particular example, we want to create a scatter plot. Okay, we want to use it to visualize relationship between two continuous variables. Remember when Dr. Olaleko was sharing our screen, we saw many columns. We saw things like name, age, salary, date, gender, and all of that. Not all of those things are continuous. So we go back to basic statistics. What we understand by continuous data. So these are data structures or data formats or data values that can hold multiple positions. They can not just pick whole numbers, which you can also call integers, but they can pick decimal values. And I'm saying this way because in our first lecture, I discovered that there were participants who do not have science background. So I'm struggling to choose my words. First, not choosing words that will mislead you, but also choosing words that everybody can relate with. So if you have values like 1, 2, 3, 4, those are whole numbers. But between 1 and 2, there are many other numbers you can have. You have decimal point. So when you say something is continuous, you can hold all through the number line. So age is an example of that. Salary is another example. In the end, we have now demonstrated what we were saying. Level 1 is called the ggplot function. The name of our data is df_csv. And then our variables are x, which is horizontal axis, will be age, y, which is vertical axis, will be salary. So it's like we are plotting salary against age. Layer 1. The next layer is what kind of graph are you expecting? I expect a graph that will just give me points. So a scatter plot is a graph that has several points in it. And lastly, what I'm adding to this is labels. I want to have a title. I'm going to pause here, go to my R code, we'll upload the file which contains the data set, and then we'll start coding. If there are questions, we can ask as I search for my file. I hope you can still see my screen. Can I go on? Can I go on?
Yes, of course. Yes, yes.
Please do, sir.
Brilliant. Okay, good.
You can go on.
Great. So we have now reached where the action really, this is the exciting part of it. So if you were on R Studio, and like you're on R Studio, what you would do is you will go to File. Instead of New File, you will go to Open File. Click on Open File. And then search for that file that you downloaded. If you click on it, it will show here as the file name. And once you click on Open, it opens the file for you. You have the file. You have the file straight up. You have the file without stress. Somebody is trying to join the call. Okay. So what I'm going to do is this. I'm going to stop presenting. And I'll ask somebody to demonstrate this. Okay. Since we are all in the same organization, once we are sure that 2-3 people understand it, then we'll be comfortable. Who wants to share screen? Have I stopped sharing my screen? Yes, I think so. Who wants to share screen? Anybody? Friday, Oboba. Hello, sir. How are you, sir?
I'm fine, sir.
Hello, sir. How are you, sir?
Fine.
Were you able to download? Were you able to download from the WhatsApp group?
I just tried.
Right, okay. Okay, you can mute your mic. Olubode Adeoye.
Yes, hello.
You want to share your screen or you are not ready?
The laptop is not working, so that's the problem I
Okay.
have.
But you are
So I'm
getting
using.
it so far, right?
Yes.
Okay. Adeseye Oguntiloye. Hello.
I'm here.
You want to share
I'm
your
here.
screen? Want to share your screen?
It's okay.
All right, let's use your screen to learn how to upload data and do some visualization. I'll be super excited if you are the people who are sharing screen and running the code. That would be amazing for me. Great. Fantastic. So have you downloaded the Excel file? Do you have it?
Yeah, I'm actually using two systems at the same time. One to this for
Wow.
the lecture, then the other system for practice. So I've downloaded it on the other system. So I may need to just do it here now.
Okay, don't worry, don't worry. I can see that merely seeing your screen, I can see that you know you are a guru in these things. Look at the number of tabs that are open on your system. Wow. Okay, let's try somebody else. Okay, stop sharing. Good. Somebody else. Who do we go to now? Let me disturb my friend. Dr. Ademola, let me disturb you. Dr. Ademola. Okay, Dr. Ademola seems not to be near his system. Adedeji Adeshina Akim.
Hello.
Yes, sir. You want to share your screen, sir?
Yeah, I'm with you.
You want to share your screen?
Yeah.
Great. Brilliant. Can you share your screen? Yeah. Someone wants to join. Who now? Let's try to add them. Oh, there are people who are waiting outside. Okay, sir.
Yeah, I'm with you.
Yes. So, you want to open your R Studio? Is it up? Click on your R Studio. I can see the icon. Yeah. No, not that one. Not that one. The other one. Yeah. Click on that. Very good. Not this one. The other one. Yeah, it's loading. It's loading, apparently. Yeah. Say yes. Good. So let the R Studio come up. It's a wonderful way of learning. And if we are able to, succeed in today's class, then I'll be very comfortable that when we now get to modeling and machine learning and all of that, we already have, a good number of, participants who are already used to the R Studio.
The R Studio is not coming up.
It's not coming up.
Not
Wow.
coming up.
Okay. So I might have to just run it here, and then you all see it, hoping that you on your own would attempt it and replicate it. Can you stop presenting, sir? Okay. So this way, we'll be able to cover more ground, and hopefully by the time you are on your own, you'll be able to demonstrate some of this. So I'm going to share my screen and then try to explain it in such a way that you'll be able to understand it at the very first time. And if not, you watch the video. So I want to cancel this file. Okay, so if you had loaded the file, I'm having a problem with explaining this stuff. Let's go back to our material. Let's go back to our material. From our material, we'll come back here. That way the flow will be very consistent. So remember what we were saying. We were saying that we wanted to produce a scatter plot as our first visualization. And we said that to produce a scatter plot, you need to load your data. So it's the loading of the data that we are looking at. So if I go back to my screen, you will see that the first thing it says here is loading ggplot2. I could do something like this. Okay, I can do something like this. So that you can get a feel of this, and I can cancel this. So if I cancel that, you will see here that the first thing that you need to do is to load this library. So if I run this line of code, what this line of code is going to do is to bring the library into my instance of R. What do I mean by my instance of R? I already have a file named session3p. So I want to make sure that ggplot2 is alive in that platform. The next thing is to bring in the data. I want to have this data df_csv. Why I wanted us to have our own, one of us do this, is because when you use read.csv, this description that you are going to see here is not the same on your own computer. If it was, I think Dr. Lalekon downloaded it. So if it was Dr. Lalekon, what you have is quotation mark C : users, maybe our own name, if she's on her own laptop, then download, and then the CSV file. So I'm going to delete this line. I'm deleting this line, and I'm writing it again so I can show you how to get there.
Dr. Masaya is a man.
Okay, sorry. Thank you very much. Sorry about that. Okay, so he is the one that I believe he downloaded it. But now I already have it on my system. I want to show you how I will get there. So I have the name of my file as df_csv. That's the name that I've given to my file. So what I have here is called an object. I've created an object. Inside that object, I want to put something there. What do I want to put there? I want to put a file. The file I want to put is an Excel file, but of the CSV format. So I'm going to try to read it using read.csv. Then I'll put a bracket. Where is that file? I know that the file is in download. So I'm going to minimize everything, show you my desktop. This is my desktop. I want to get to my download, so I'll click on this envelope, this folder. I'll go to downloads, click on downloads, and then see my file. Once I get to this file, I can right-click on it. When I right-click on it, I'll copy the path. Let me do that again. It's important to do that again. So I'll go here, click on this envelope, or this folder, or this directory, go to downloads, click on downloads, look for the file because I downloaded the file today. and then I'll right click on that file and I'll click on copy path. What I'm doing is that I'm copying the directory, the direction, the location of my file. Once I've copied that, I will go back to my RStudio. Remember that I have created this object and I want to assign it. I want it to read a CSV file, and that CSV file is located somewhere. So I'm going to put quotation marks, double, and then I will attach it. You can see that it's giving me double quotation. So sometimes you don't need to even put the quotation marks. It will bring it there by itself. It will bring in the entire file. So if I done paste, it brings it with the quotation marks. Now, sometimes when you run this, you run into error. Sometimes. So if you don't, good. If you do, one way is to change this double backward slash to, sorry, this single backward slash to double backward slash. Why I wanted you to demonstrate it on your own was that I wanted you to run into these errors and then we'll correct it for you. But don't worry, you are still accomplishing the same task. If I now click on this run and I see that there's no error, it means that it has taken this my file, which is inside download on my computer in the portion called users inside my C drive. It has read it and has now saved it in a new name, which is df_csv. If I want to confirm that, I can ask it to print bracket df_csv. And when I run that, it will give me the file. So that Excel file that I had before is now here in my RStudio. Okay, we see that it has 100 observations. We want to get the names of the columns. We will get them. The names of the features, columns, the variables. Name, age, salary, department, gender, date, religion, and sales. So in terms of visualization, the first visuals that we want, so what I'm going to do here is that I won't really go back to our PDF anymore. I'm going to stay on this R code and take my time. We're in RStudio, and they will keep running different types of plots, allowing you to stop me to get, to give me your own views. So notice that I've dragged this thing. I can actually make this small and I can make it bigger. I'm dragging it because this session that we have not used before today becomes useful. We have touched on it before, where we said that we can actually check our packages here. If I scroll now, notice that these packages don't have these boxes ticked. But if I scroll to ggplot, you will see something interesting. So when we get to ggplot2, it's ticked. As some other things are ticked, I will tell you why as we progress. So we want to have a visualization plotting age against salary. The first layer that we need is to use this ggplot function. And then what is the name of our data? Our data is df_csv. We put a comma. What are the axes that we are considering? We are considering age on the x-axis and salary on the y-axis. That's the first layer. On top of that layer, so we say plus, press enter and come to the next line. We want what kind of plot, what geometry, how do you want it to look like? I want it to just give me points. And that's a function. So this is going to give me points. I can actually stop here and have a graph. But it will be okay if I have a graph that doesn't have labels, no title. So I will now add plus and say, yes, I want labels. The first label I want is the title. I want the title to be, notice that there are quotation marks here, scatter plot of age versus salary. Then I put a comma there. And then I say on the x-axis, which is horizontal, make it to be age. and on the vertical axis, make it to be salary. If I run these 3 lines of code, anywhere you put your cursor here, it will run the 3 lines together. So if I put my cursor like here and I run that code, it will give me this plot. So this is our first plot. On the horizontal axis is age, on the vertical axis is salary, and we can see how the plots are scattered. I can actually publish this. Okay, I can zoom and it becomes bigger. Okay, I can cancel that zoom. I can even export this to PDF or save as an image. So like this plot now is useful for publication. Okay, I can even do presentation, and there are some other things that we can do here. However, it is not enough for us to have a plot. It is better for us to be able to make, get meanings from this plot. From here, we can see that maybe the minimum salary is, these values here, which look like maybe about less than 5,000. And here we have something over 100,000. And, we can see that somehow the oldest person is like 60 years. And unfortunately for this person, his salary is small. Maybe he's a security man. But there's somebody here who is 50 something and is earning over 100. Maybe he's a local government chairman, and so on and so forth. So we can make meanings from this plot. But this is not sufficient because it's not looking too great. So there's also a need for you to understand the kind of plot that will give you the information that you would like. So we move on to say enhancing scatter plot. So we want to make this scatter plot look better. All we just need to do is just adjust the code. Notice that line 16 still tells us first layer ggplot. Your data is df underscore csv. What are your axes? X is still age, Y is still salary. But now we want to have different colors. This is going to produce what we call legend. And then it's good for us to go back and check our data. Okay, so I have data here. I can click on this, and then I can now get the variables. Look at the columns: name, age, salary, department. In terms of department, we will see that there are varying departments: marketing, IT, and so on. But we can also visualize it. How? By making department to be an axis. For now, we are not making department to be an axis. We are making department to show us the different departments and their relationships, in terms of age and salary. So now we are bringing in three. Okay, somebody joining. Okay, hold on a moment. That was a very good break for us. Is somebody joining? How do I go now? Let me make this full screen. Somebody is trying to join. Yeah, okay, Jamie. Great. So let's go back to our R. That was a good interjection. So the difference between line 11 and line 16 is that before we add the next layer, we are adding what we call a legend here. And we are using department to, show the different classes. So if you go to line 12, you will see that here we just gave instruction that you should give us only the points. But here we are given more information about the size of the points. How big do you want those points to be? And then regarding alpha is how much of impression in terms of the thickness, in terms of the gradient. We are going to tweak these values and then you see the difference. Then in terms of the title, we still want a scatter plot, but we said, let's just adjust it and say with coloring grouping so that it will be different from scatter plot of age versus salary. So if I run this line of code, watch this graph, it's going to change. So I run that, we have a new graph, which we can zoom. This is a new graph now. It's still the same old graph. So this man who is 60 and earning so little, I think this color is H, no, is what color is this now? IT. How can an IT staff be earning this low when another IT staff here is earning that much? Okay, who is the youngest person in this group? There's somebody, there are a few people here who are just under 20 or about 20 years old. There's one in finance, and stuff like that. So you now have more information. I can stop this and then go back using this arrow to show us the previous plot so that we can distinguish between them. So this is the previous plot. We can see those points. But with this new plot, we are getting more information. And if you are not too satisfied with that, we can make this larger by making it maybe like 0.8. And then let's make this 0.9 and see the difference. Let's run that. See what has happened. So with this 8, this thing is now bigger and thicker. So these values here, you can actually tamper with them. I hope this is making more sense. So let me reduce this. Okay. And then we now want to add titles and labels. Instead of just, having scatter plots with color groupings. So what do we say? If all we want to add is the title and we don't want all this legend stuff, we can go on and say ggplot. See that we did not even say data is equal to df underscore CSV. But all of this is still the same. We are saying we want a scatter plot. We said we want our label to be age versus salary. So if we run this line of code, we have a different plot again. Can you see how quickly the plot has changed? Just by tweaking, a value. Let me pause and receive feedback. Are we getting what we are doing? Because we are
Yes.
still on scatter plot. Thank you very much, sir. So today's lecture is easy because I've sent you the file, I've sent you the data. You take your time, download the file and the data, and please feel free. If you're having issues, just send me a chat. If I don't answer you on time, be sure that I'll eventually answer you. Okay, so let's go on. So now we want to add annotation, to this previous one. So what we are saying is we've gone from the very first graph. Somebody's raising hand, I think. Let me go back and confirm.
Hello?
Important. Yes, go on, doctor.
Yeah, I want to ask, do we assume that the code has been done? Because what I'm seeing on your screen is as if you have done this code already.
Okay,
I'm
good.
just taking us through how we can manipulate the code. Am I right?
Fantastic. Correct. That's it. You are very correct. So it's like this is straight from Prof's notes. So it's this note that we were looking at before that we are rerunning this PDF. So what we have is, if we continue, you will see that it's the same thing. Okay, then we can now begin to look at another type of plot. So in today's PDF file, Prof helped us, with different kinds of plots, and he gave us a practical example. But at the end of the class, we will expect us to look for a fresh data set and then using this code, but we'll now tweak. Instead of using df underscore CSV, you use another data set. Don't worry, we'll get there. Okay, so the answer to your question is yes. The code is already there, and we are just reading it and then changing it. Not that we are writing the code from scratch. I hope that answers your question. And this is very useful because in the first 2 weeks, the challenge we had was that we wanted you to be able to reproduce what we were doing. And if this really works, it means that we would have prepared ourselves very well for our next class, which is also very, very interesting. That's modeling. That's very interesting. So now we want to add annotation. What I want you to recognize here now is we now change this to, we are using annotate. This label here is going to appear inside our plot. But in this example, we are picking on specific values. We want to capture this X35 and Y 70,000. And we want to make sure that it goes there and puts this key insight in the color red. So what I'm going to do, which in a way answers what Dr. Demola was saying, I'm going to run this code, then I will start changing values. So that when I start changing values, you will see how changing values affects the graph. And then you know what to tweak when you are working on your own. So let me run any of the lines between 26 and 28. Let's just run that portion. And then we have a graph. We have a graph. First of all, what is written here is key insight. That is because that's the label that we want. Secondly, this color is red. It is so because we specified red. Again, this size is this size because we put 5 there. Most importantly, this text, that is this key insight, is located where X is 35 and Y is 70,000. Let me show that. So key insight, the middle of key insight, if you scroll down, is at 35, age 35, and here 70,000. Let's assume that we want to play with this. I can actually copy these lines of code. Let me copy these lines of code. Let me see if this will work for me. So I've copied that line of code. As we get more experience, we'll show you some of these tricks, shortcuts. So now we want age, but we want to pick not 35. We want to pick 50. We want to pick 90,000. We want to pick my friend, Dr. Ademola. We want to pick him. And we don't want it to be red. We want it to be green. So we'll write green here. And then we want the size to be big. So maybe we'll make it like, say, 10. So let's run this and let's see what we are going to have. We can pick anywhere here. So you see, let me make this big. What do we have? Dr. Ademola. The middle is around 50. The amount is close to 100,000. And then it's this big. So what are we saying? We are saying that once you understand the grammar of graphics, and you know that they are put on layers, and you have this code, and you are doing your own project, all you just need to do is change the name of the data set, know the variables that are in your data set and put them correctly, tell us the kind of plot that you want, and you can do a lot of things. And then R does the rest for you. Isn't that interesting? So that is for scatter plots. What if it is bar plot? Don't forget, we are statistician majorly here. Bar plots are used when you realize that the feature you are looking at as a variable is in categories. Okay, but otherwise you use histogram. Okay, so we want to visualize categorical data. That's why we are talking about bar plot. They are used to visualize categorical data. For instance, the count of employees by department. We want to know how many employees are in each department. And you know the interesting thing, this you still use the ggplot. Our data is still DF under CSV, but our aesthetics now is not X and Y because it's just a bar. So we only have one axis that we are considering, and that axis is X, and we want the axis to, take the departments. On top of that, what do we want it to plot for us? We want bars. That's why we are doing geom underscore bar instead of geom underscore point. And finally, we add the label. The title will be employee count by department. And what we are going to have is on the x-axis is department, on the y-axis is count. If you don't like count, let me put an S there. So that when I run this code, you will see that it is S that you find there. So that's our plot. We can zoom out. And then look, this already gives us, this is the power of visualization. So we now see that there are the highest, the departments that has the highest number of employees are IT and sales. They are almost equal. If they even look they are equal. Then follows finance, and there are few people in HR. But you see, even though we get the information from this graph, it's not looking great. Now, because it's not looking great, then we can now add, parameters. What do I mean by parameters? Inside this bar, we can now do a lot of tweaking. But before we even do that tweaking, we can go back to line 43. I haven't said that we need department to be X. We can use a function, an argument called fill. So what this is going to do is that it's going to give different colors. Just this line, this addition. And then you see that line 44 still looks exactly like line 39. And then we now add theme underscore minimal. It is this function that is going to act on this department. And then you have a beautiful output. Line 46 is still the same. So if we run anywhere between line 43 and 46, we have a new plot, which, looks even more colorful. So like we said at the beginning, that's the beauty of grammar of graphics. As you change, and that's the difference between using programming languages to do this visualization and using other tools like Power BI, and, other drag and drop tools. They are okay. Nobody is saying that they are not okay. But we are saying that it doesn't give as much room for maneuvering as we see when we use R. Okay? So again, we can change the theme minimal to another one here, which is theme classic. Let's see if we can really see the difference. One difference that you will see, which is a very clever thing that has been done here, is that just look at the titles. So even if they are looking differently, you notice by checking the titles. Okay, so this is, what color is this? For now, let's call it orange. What will we now call this? I don't know. This is green, this is blue, and this is purple. So let's run this portion and see what we'll get. We have a new graph, which is exactly the same thing, which means that this theme minimal is the same as this theme underscore classic. How do we know that? If we go back to this arrow, we will see this one has a title bar chart with colors. And if we move here, we'll see this one says customize bar chart. And they are giving us the same thing. But notice a difference. The x-axis here does not have a line. And the y-axis here does not have, the x-axis doesn't have a line showing increase in x-axis and increase in y-axis. So that's what this new adjustment will do to us when we pick theme underscore classic. Because if I change here, you will see that it now helps us to calculate these values appropriately. If you are not getting it, I'll go back. This is the first one when you use theme underscore minimal, and this when you use the theme underscore classic. So we have seen scatter plots. We have now seen bar charts. We now want to do heat maps. Okay? And the good thing about what we are doing now is when I'm done with this, I'll take us back to the lecture notes, and then I'll add another file. I'll start off that file, or maybe I can run through the file, share it with you, and then you use that to practice so that you can see how some of these things work. So creating heat maps. Okay, so the question now is, what do we need heat maps for? Okay, so what heat map does is it also captures the frequencies where you have higher frequency having specific colors and lower frequencies having a different color. So what do we have here? We have first, in creating a heat map, We take our ggplot function, we pick our data set, we need the x-axis to be department, but now the y-axis to be the region. Region is now south, north, east, west. Then we now use salary for our field. Then again, because we are doing heat map, we don't actually now need a line. We don't need bars. We don't need points. We just need boxes, which we call tile. The way heat maps are, they are like squares that are arranged in rows and columns. They are like the tiles you have in your room. So that's why it's used this tile function. So we are not looking for bar, we are not looking for point, but we are looking for tile. Then our label will be salary heat map. Okay, so let's run this line 55 to 58. And then it says unexpected symbol in its map because I only, highlighted its map. That's why you have this error. So if I click on the screen and I'm not highlighting anything and I run the code, it is going to give me these tiles. But you cannot interpret the tiles except you understand these legends. Okay, so you can see that as it goes from dark to bright, the salary increases. So in each of these tiles, you can capture the relationship between region and department. Seems to me that people in HR are earning so much, and the people in sales, especially people in the west, south, and the east, they are suffering. Okay, so what the heat map does is it gives you an idea of relationship among three variables, showing where you have the highest intensity. Lastly, I think we have the yes. Okay, I think there's more. There are other plots. Very good, brilliant. So again, faceted plots. This one now has to do with multiple plots. Multiple plots. So if we, without even, trying to explain some of these features, you can see that again, this kind of plot has X and Y, which means it will look like a scatter plot. To confirm that, we are going to get points, but there's now an additional argument which will wrap the points together. So let's run this code and see what we are going to get so that we can use this to describe. So what it does is it picks each of the departments, finance, gets us a scatter plot for it. It goes to HR, gets a scatter plot, and instead of having a general scatter plot, it now picks each of the, departments, because here we have said that it should use department. This tilde, symbol says that section them into departments. Use departments, to give us the different categories. Let's do region. Let's do region here. Let's do region here. I'll run this code and see what we have. You see that now that we have changed this to region, it still gives us a facet, scatter plot. But this scatter plot, this scatter plot is now using the different regions. Again, I want to say to us that this code that you already have is like a template, so that at the end of the day, on your own, you can build on it. Moving forward to line 65, we can now, have two variables. If you compare line 66 to line 60, you will see that the first few lines are the same, except that when you now get to the facet wrap, he uses facet grid here. The difference between the wrap and the grid is that the grid, okay, let me just share this. Look at this plot, and then let me run this, and then you see the difference yourself. These are now, let me go back and show you this. Can you see east? Let me use the same, let's use the same variable. So let me come here and use department. Department. Somebody is distracting me with a call. That's why I'm having this stress. So we have finance, HR, IT, marketing, and sales. But let's check the previous plots. You can see finance, broken, HR, IT, marketing, sales, but we now have female and male. Let's go back here. We didn't have anything that looked like that. How do we see the difference? Here, we have included gender. But in Facet Trap, we're only looking at departments. But in Facet Grid, we have gender and department. So if you want to confirm that again, you see that it has now done even a clearer comparison. So you see, like we said at the start, these visualizations are enough to communicate. I zoom out this, you will see that it becomes even more impressive. Let me add this person to the class. We wish that everybody joined from scratch, but we also are glad that there's a video that everyone can watch. So let's go to our R. Brilliant, brilliant, fantastic. So we can facet by two variables, but we must indicate the two variables that we are, focusing on. So we have seen scatter plot, we have seen bar plot, we have seen heat map, we have seen facets. Now we want to look at line plots. And that brings a new data structure. So there's df underscore ts, where ts is time series. So if we run this line of code, we have an error. Why? Because there's no file like this. So what we can do is, first, let's go to our classroom. Let's start from there. Let's see if that file is included in the classroom. So before I leave here, I want to show you what we have been looking at. So we have done bar plot. We now want to do line plots. And we are saying that to do line plots, we need time series data. Okay, so this might not be df underscore csv. It will be a different, data, which is what we want to bring in here. So we are actually planning on running this remaining code as we end this lecture. Okay, so we are almost done. However, we need to close this PDF and then see that we also have that data. So I'm supposed to download this data. Okay, this data is important for me to download. So it's also an Excel sheet, but I open it as a Google Sheet for me. And then from this Google Sheet, I can see that it's time-based from January 1st. Scroll down, checking the relationship between the sales. So this could be your business, your supermarket, your shop, and you are recording the sales, per day from January 1st to where now? April 9th. So this is a different data set. So I'm going to go to File. I'll download as a CSV file. So now it's on my downloads. So let me open my R. If I go to my R, I can actually download that data. But what I want to do is, I want to change this. How do I do that? I'll go to my folder here. I've done this today, but I'm just trying to do it again. Go to downloads. This is the file I just downloaded. I don't like the title. I can change the title. Okay, so I just want it to be df underscore ts. Then I'll right click, copy path, and that's all I need from here. I'll go back to my R, use that to replace this here, paste. Again, I made that mistake. I don't want to put I don't want to put the quotation marks. Why? Wrap, Control Z, Control Z, Y, Control Y. Why is this giving me this? Okay, no problem. So where are we? Here. So let me cancel this. And let me just paste that direction. So if I succeed in pasting that and I'm able to remove the quotation marks, let's try to run. Sorry, please, for a moment. Read the data. Why is this giving me issues? It's giving me issues. Why? Maybe from a previous line.
I guess this is the double slash.
No, it's not. It's not the double slash. It's a previous line. That's where the error is. So because this is my file, I can actually copy all this. I can cut it. You know, it's my file. I can go anywhere and play with it because it's giving me headaches. So I'll paste it there so that I won't have problems with that portion. So I don't have a problem with that portion. So what did I do? We have a new data set and it's a time series data structure. So we now, I now want to call this df underscore ts, okay, to distinguish it from the previous one. So if I run this line of code and I get this error, then what my friend was saying will now become useful, that double backward slash, which actually I wanted you to experience by yourselves. But don't worry, as you go on, you will experience it. And then you watch this video to correct yourself. So it loads it. But as usual, we want to check the data. So we can go and do print df underscore ts, and then we run that, and we have our data. We now want to plot. What do we want to plot? We want to plot a line graph, a line. We have seen scatter plot, we have seen bar plot, we have seen heat map, we've seen faceted, and even with grid. Now we want to plot a line graph. We just want the color of the line to be blue, and this will be the label. So if we run this line of code, we'll get our graph, okay? But I don't seem to like, this graph is not giving us any information, which means that we need to add markers to the line plot. There might be a line here which we are not really seeing. This is the line here at the base here, okay? So there needs to be an adjustment of this grid, but we'll come to that later. So let's make this plot better. How do we make this plot better? We want to, increase the size of those plots. If you check properly, you will see that line 8 and line 14 are a bit different. The difference is that we have now brought in group, okay? Then line 9 and line 15 are exactly the same. We've now added an extra line, which is line 16. You know, when you plot a graph, you are supposed to have points. So let's see how that one will be captured. So now we now have the points showing clearly. So the lines are those blue things that you see. The points are those dots. For a better view, you can make that to be 4 so that the points can be clearer. You see that they are now bigger, but it doesn't look great if you make it to be that big. So we'll go back and then we have that. Okay, so at the end, we have come, to the end of that file that Prof gave to us, and we have run everything in that file. 2 things that I want to do as we conclude this class. Number 1, I want to go back to our classroom, look at our PDF, scan through to show you that we have covered the content for today. Okay, so we'll go and then I need to move this away. I need to move this away. So I'll click on this again. So we scroll down. We have seen what data visualization is about. We've seen the benefits of visualization. And I said we are coming back to this. So we're able to identify the patterns in the graph. We saw one 60-year-old person who was earning very, small amount of money. And then, with the heat map, we're able to, see where some regions were really suffering in terms of their remuneration. And then with that, we can begin to make very useful decisions. And like we said, we're able to capture insights by using different kinds of plots. And we said that it's a grammar of graphics built on layers. We had the ggplot function. And when you have geom underscore, what kind of plot? And then we can adjust the appearance. We loaded the ggplot, and then we began to look at different kinds of plots. First of all, we did scatter plots. Then we went on to do bar plots, and then tried line plots with a new data set. And then we added markers to it. We could have also added aesthetics to the scatter plot, but instead we added aesthetics to the bar plot, and we're seeing different kinds of colors. We used the theme underscore classic, and we saw the difference between that and theme underscore minimal. And in addition to that, we added labels. We're able to do annotation with our friend Dr. Ademola's name. And then we went on to look at heat map. We created our heat map, saw how, like we said, some areas were enjoying more. And we did facet wrap for one variable, and also facet grid for two variables, gender and departments. This will be your hands-on practice. So I'll copy this for now. Go to, where are we now? Our classroom, paste it there so that everybody can have it. And then I'll go back to my R Studio and then look for a file that I created for us, which I called FSS_3 visualization. First and foremost, I clean up my screen. It's like wiping clean your whiteboard. Okay. And then we have a clean slate, talking about clean slate. So in this instance, first and foremost, we are going to add more packages. I told you that ggplot is a very good package, but there are other packages that we can use to produce even more interesting plots. That's the beautiful thing about R. So apart from ggplot2, there's dplyr, there's ggali for correlation map, and there's grid extra. So just watch this. When you're watching again on your own, make sure you slow down the recording and then try to implement them. Remember that if you are running this for the first time, the dplyr, if you have not used it before, you might need to install the package. The same thing with ggali and the grid extra. These ones are not going to be easy for you to just library them. You need to first install the package. Now, the data set that I have here is the breast cancer data set. So what I'm going to do, I hope I will remember at the end of this class, I will drop the data set into your, what's it called, our WhatsApp group. So I've decided to call this data. I'm reading from my own, computer. So when you download, in this case, this breast cancer is on my desktop, not on my downloads. So if I run that, it sees it. In line 19, I want to check the structure of the data. I click on that, and it tells me, look at the variables that affect, the chance of somebody being diagnosed of breast cancer or not. Okay, so the radius, the space that it occupies, the texture, when you feel it, the perimeter, the smoothness, the compactness. Now, why am I doing this? Because there are so many variables. So this now becomes a real practical application. Okay, breast cancer is a serious matter, and you can address it using data science techniques. Okay, this is one instance where, first of all, you need to get the data, and there is a sample data that exists on the internet. Okay, good. So what do? We want to convert the column diagnosis. There's a column which is diagnosis. Okay, we want to categorize them and change them to B and M, where B means benign and M means malignant. Benign means that it's a tumor, but it doesn't have cancer in it. Okay, malignant means this tumor is cancerous. In some other instances, you can use 0 and 1. So this is an example of a binary situation. So what am I doing here? I'm doing, data wrangling. I'm doing pre-process. I'm picking the diagnosis column. That's why this $sign is there. So if I run line 22, I would have created a new variable called data on diagnosis. So I want to check the distribution. I want to check the bar plot for the two. I want to see if they are more benign or more malignant. So what do? I use my ggplot. The name of my data is data. My aesthetics are on the x-axis diagnosis, and I want to fill it up with that same variable. Then I build on top of that a biplot. I have my pi tool. Okay, on the y-axis is count, or it can be frequency. If I run that line of code, I'm going to have this bar chart. So from this bar chart, you see more. Somebody is trying to join. By the way, we have just 2 minutes to the end of this very, intense class. This has been very intense. I wish that we have learned enough. But this person is not joining. Okay, so let's go on. So we have these plots. Clearly, more benign, which is good news. Okay, all right, we move on. We could also do histogram, but this histogram has to be on numerical data. Okay, so we are looking at the thickness of the lump. Okay, and now we are using radius, the mean radius, as our x-axis. Still filling up with diagnosis. That is benign or malignant. That will separate them. And there are some other, parameters here that we might discuss maybe as we progress. Okay, not just today. I promise to just run the code. If you run that code, you see you have a histogram separating malignant from benign. Okay, so it seemed to me that from this graph, the moment the average radius gets bigger, the more likely that tumor is cancerous. Can you see? Larger radius shows more likelihood of cancerous cells. Then you go on, you can build a density plot, which is just like a curve on your histogram. Okay, so you have a curve on your histogram. That's a density plot. And then we can do a lot more. So I can get your box plot, which helps you to, uncover outliers and extreme values. And there's still more that we can do. Okay, you can have your scatter plot. And you can see from this scatter plot that as the mean radius, so this scatter plot is similar to that, histogram that we saw the other time. So as this radius gets larger, and the perimeter also gets larger, of course. Bigger radius, bigger perimeter. Perimeter depends on radius. So they are the radius, they are the perimeter. And then you can also get violin plot, which is like a pure violin. You can do facet grid. And then you can capture correlation heat map. And then you see that this one looks even very interesting because it has numbers inside. And then you can do multiple plots, lots of plots together at the same time, and all of them in one, in one grid. All of them together now. Okay. So this file will be sent to us maybe towards the end of the week, when you would have practiced the other ones, so that this will not serve as a distractor. My friend Dr. Demola will surely remind me of it. So I don't have any doubt. Anything that I'm supposed to do, if I don't do it, it reminds me of it. Thank you very much, everyone. If there are questions, please go ahead and ask your questions. If there are none, enjoy your evening.
Thank you very much.
God bless
Thank
you.
you so much.
God bless you, sir.
Thank you.
Hello, sir.
Yes, sir.
Before we take a leave, please, I want to ask this question that is bothering me. What's the difference between write and read? When do
Okay.
you make use of write? And I know read, read, you have to import, so to say.
Okay.
I get it right.
Correct. So you can create a file of your own. When you
Okay.
create a file of your own, you are writing your file.
Okay.
But if it's somebody else's file that you are downloading, you need to read that file.
Okay.
So let's say I have a file, maybe on tuberculosis prevalence in Oyo State, and you want that file. When you get to your system, you will read it. But if you want to send to me, you will write it, and then I'll read it. We will still demonstrate those things as we go on.
Okay. Okay.
God bless you.
Thank you so much.
I
All
also
right,
have
God
a
bless
question.
We appreciate
Yes,
you.
go on.
Like, when
Let me see.
when the classroom was going on,
Hold on, man. Let me stop the recording because of time. I'm stopping the recording now.